Hello, my name is Joseph Maxwell, and here is the video deliverable for the blockchain homework assignment. I'm going to just quickly get the questions out of the way first. What happens to the nonce of a block if the data in the block is changed? The nonce itself is unchanged. It is the key to determine if the hash is signed and valid. What does change is the hash value for the node. To give a quick example, I have here the block example website. Here's the nonce value, and here's the hash. If I were to change the data at all, the hash value has changed, but the nonce has not. It has changed to a red color to indicate that this is no longer a valid block. What it means to be a valid block is that the hash value starts with 4 zeros. This determines that the block is signed and correct. Now, the nonce, how is the nonce of a given block calculated? As mentioned previously, the nonce is the key value to determine whether the data is correct with the hash provided. So the nonce value is calculated from the data and would provide a hash value that starts with 4 zeros. If you wanted to mine a block to take 5 minutes instead of 5 seconds, what would you change? Within the PowerPoint presentation, it is told that in order to make it more difficult, you would increase the number of miners. The more miners there are, the lower the threshold value for the hashes. The lower the threshold, the harder it is to mine. Conversely, less miners, the easier it is to take. Now, as for the code for a chain block, I have a copy right here. And once it's written out, I have placed out 5 separate tabs within Postman for each individual section of the code. The first section is the mine. With this, every time that I create a new node by mining, it also creates a new coin to a new person. This node also includes a hash value for the previous node, which initially for just one chain isn't as useful until you get down to the consensus point. So let me create a couple of nodes here. I think probably 10 would be fine once I hit index 11, that is. And finally, moving on to transactions. The transaction is taking a sender and it is sending it to a receiver. I'm actually going to quickly skip this, go to a chain, and I'm going to grab one of the recipients who has been mining, and he is going to send it to somebody else. So I'm going to send a transaction. It will be in block number 12. Going back to the chain, if I were to reload the chain, I'm going to have, oops, is it not there? Transaction will be added to block 12. Go back to mine. Ah, here it is. It hasn't been added to the next block that has been mined by somebody. So I now have a sender here, whereas in previous mines, it was just a 0. Now it's got a recipient for that transaction. And going back to the chain, there is now a 12th node. This node includes a transaction along with it. And finally, as for the consensus, it's taken a separate node, which I have created a second one that is running simultaneously to the first one. And with this, I will be able to provide a consensus. It is two chains in parallel to each other that are double checking to make sure that the chains are identical to each other. So I will register this new node set as, well, a duplicate. And I am going to resolve any issues that are within it, which will go down the chain recursively from the very last one to the very first one, checking to see if the previous hashes connect to the correct chain and that the proof within the hash is correct. And finally, at the very end, it tells us that our chain is authoritative. In this case, it absolutely is, because simply I had just duplicated it into the first one, from the first one into the second one, and then finally checked it, seeing if the duplication was a duplication. Now, if I were to take the first one and mine some more with a couple of transactions and try to resolve again, it will resolve it adding on the new transactions to the second blockchain. This will then make it an authoritative copy once again. What this does is it looks at the two chains, determines which one's the longer one, and then adds that one to the end of the shorter chain. Thank you for listening to me ramble a bit. Hope you have a good evening.